Tuesday. Once again, hopefully you've written these down, made some notes. Hopefully you refer back to some notes from Tuesday if you've forgotten some of the key skills. That is all part of revision. It's absolutely fine for you to sit there and think, oh, I can't remember this. Go back to your notes, have a look. All right, okay, yeah, I think I know how to do it now. Okay. So, question 1. 3/8 times by 11. Give your answer as a mixed number. So when we're timesing a fraction by a whole number, we need to turn that whole number into a fraction. So essentially, let me get my pen ready. There we go, 3/8. I want to write it 11, that 11 there, as a fraction. It's going to be 11 over another number. Can anyone tell me what the bottom number is in order to turn 11 into a fraction? What does that bottom number need to be? What are you saying? What? Mo's saying 1. Excellent. Yeah, we do need to turn it into 1. Now, that's a really good, that's the first step. The second step is to know what to do when you multiply fractions. Now, the good thing is when you multiply fractions, it's actually the nicest thing to do. You times the top numbers together and you times the bottom numbers together. So, ready? 3 times 11 gives me 33. 8 times 1 gives me 8. Now, that right there would give me 1 mark, but hopefully you can see here, this is a 2-mark question. And it says here, give your answer as a mixed number. Now, that's where our second mark comes from. So if any of you have got 33 over 8, good, because you've at least picked up 1 mark. For those of you who want to go for that second mark, let's look at converting it into a mixed number. So I'll change the colour of my pen for this. How many 8s go into 33, and what is the remainder? So 2 questions in one there. How many 8s go into 33, and what is the remainder? That's the question. 4, remainder 1. Yeah, well, 4 times 8 is 32. Yeah, so there would be a remainder 1. So 4 with a remainder of 1. And remember, a mixed number is a whole number, an integer with a fraction beside it. And we always keep the 8, the bottom number. Okay, so it would be 4 and 1/8. So 2 marks for that, 1 mark for that. Okay, not a bad start, guys. Not a bad start, because I can see a few of you have had success there. And those that haven't, we're looking and we're learning, which is really good. Okay, now question 2. Oops, I've got ahead of myself. Question 2, work out 1/4 plus 7/10. Give your answer as a fraction. So what we need to do with this sort of question, we've got to add those fractions together. Okay, so, and you'll notice I'm going to say something that links back directly to Tuesday in a second. But the bottom numbers, if they're the same, keep them the same. If they're not, we have to make them the same. 4 and 10, they're different bottom numbers, aren't they? They're different denominators. So what we need to do is multiply those 2 values together in order to give us fractions with the same bottom number. So 4 times 10 is 40, like so. Okay, are we happy with that? Hopefully. Now, this is the question we have to now think. How did I get from 4 up to 40? I timesed it by 10. And whatever I do to the bottom, I also do to the top. So I do 1 times 10. 1 times 10 is 10. Okay, put a little add symbol in there because we are adding these fractions. Then I think, how did I get from 10 up to 40? Well, I timesed it by 4. And whatever I do to the bottom, I do to the top. So 7 times 4 is 28. Once we've done that, we've actually done the hard work now. This is the nice bit. We keep the bottom fraction the same, so that stays at 40. And then we do 10, add 28, which is 38. Now, do I need to simplify? Do I need to simplify my answer there? What do you reckon, yes or no? No, James is spot on. We don't have to simplify it because it doesn't tell me to. It says, give your answer as a fraction. That is a fraction. So I've satisfied the criteria that they've given me, if that makes sense. I've kept the examiner happy. Now, if you have simplified it, that's fine, but make sure you simplified it correctly to get 19 over 20. So what you don't want to do is simplify it, make a mistake, and then lose the marks. Does that make sense? So sometimes it's better just to play it safe and leave it as it is. Okay, but yeah, 38 over 40, 19 over 20, spot on, 2 marks for that. Okay, that is multiplying and adding fractions. We are now going to look at standard form. So standard form, write 360,000 in standard form. So you'll remember what I like to do first and foremost is write the number out again, but give myself a bit more space to work with. So 360,000, okay? Now, the standard form, we have to put a decimal point into the number, okay? The decimal point always goes in after the first number. So can you see where it says 3? There goes my decimal point. So it becomes 3.6. We'll write that down at the bottom here, 3.6. Okay, now the standard form, we need to remember that it's times by 10. And then the last thing we need to do is work out the little number, the indice, okay? And we do that by counting. So the decimal point would normally be the end of the number. We need to count how many jumps it takes to get from here to the end. 1, 2, 3, 4, 5. 3.6 times 10 to the power of 5. Now, if I go on to the next slide on decimals here, looking pretty good there. Lots of you got 3.6 and lots of you got 10 by 10. Yeah, just make sure it's the number of jumps that we're counting, but you guys look like you've consistently got that spot on. Now, this next one, slightly different now because we're going from a standard form back into an ordinary number. So what we need to do, we've got 9.2. And you'll notice straight away, I've moved my numbers a little bit to the right. Now, that's because I've spotted it's a -3, which means the number's going to be small. So what does that mean? Well, the number, the decimal point, is going to jump 3 places to the left because it's getting smaller. So 1, 2, 3. They're my 3 jumps. The decimal point is now there. What goes underneath the gaps or underneath the jumps? Zeros. And then, like I said on Tuesday, I like to put a 0 before the decimal point as well, just to keep it a nice, neat package. So 0.0092. Now, these are only worth 1 mark. But if you can do this, just think about these extra little marks that add up. Okay, small but helpful goals, small but helpful steps in the right direction, if you ask me. Okay, and then question 5A. Ooh, I know what's coming up, you see. I know question 5B is a nice question. Okay, is it 75? Which one? Which one am I? Which one? We've got 0.0009. Oh, for B. We'll see. I think it might be. But I can't remember. I think it might be. Okay. Right. 0.0097 is standard form. So remember, the decimal point goes after the first proper number, which is there. Okay. So it becomes 9.7 times by 10. Now, how many jumps does it make? 1, 2, 3, 4. Well, it's a small number, isn't it? This is a teeny tiny number. So we put a little -4 in there. Okay. Teeny tiny number, little minus. Okay. Now, I know I'll probably embarrass myself saying teeny tiny, but that's what you got to do. To help things stick in your memory, you have to do silly little things that help it just stay in there. Okay. Now, this is 5B. This is the one which I'm really hoping that we have a bit more confidence with in terms of the exam. Now, on Tuesday, we didn't look at a question like this, so I kind of chucked it in there, but I want to see how we get on here. Okay. So 3 times 10 to the power of 5. I need to make sure I give myself space here. And then divided by 4 times 10 to the power of 3. So what's going to make my life easier is converting those standard forms into actually ordinary numbers. Because remember here, the answer needs to be an ordinary number. So the sooner I turn it into an ordinary number, the sooner the better, really, isn't it? So here we go. 3 times 10 to the power of 5, so 3. Okay. And the decimal point is at the end of the number, okay? And it's going to make 5 jumps to the right because it's a positive number there. So 5 jumps. Are you ready? 1, 2, 3, 4, 5. The decimal point is now there. 0, 0, 0, 0, 0. So what I'm going to do, I'm going to rewrite this equation down here. So that top number has got 3 followed by 5 zeros. Are you ready? 1, 2, 3, 4, 5. That's going to be divided by, let's do the next bit, 4 times 10 to the power of 3. So 4, the decimal point would be there. And it's going to make 3 jumps to the right. 3 jumps. 1, 2, 3. And then what we're going to do here, get the blanks with zeros in. So 4,000. So let me just change this number here to 4,000 now. So if you've got either 300,000, no, 30,000, sorry, or 4,000, okay, you've picked yourself up a mark, okay? At least 300,000, isn't it? I've missed off a 0. 1, 2, yeah, sorry, there we go. There we go. Really crucial, actually, that, because obviously when you see a lot of zeros, they do become blurred, and like I'm literally a victim of it right now, where I've thought there was 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Excellent. 1, 2, 3, 1, 2, 3. Okay. Yeah. In your exam, just make sure if you've worked out there's 5 zeros, make sure you write your answer down here with 5 zeros. Okay. Now we're doing 300,000 divided by 4,000. It's quite a large number. Okay. So what we're going to do, let's cancel out the zeros. There's 3 zeros down here we can get rid of. So we can get rid of 3 zeros up here. So what does that leave me with? Well, it actually leaves me with 300 divided by 4. And a quick way, a nice way of dividing by 4 is halving it and then halving it again. So 300 halved is 150. 150 halved once more is, as Mo said earlier, 75. Okay, so it's only, I say it's only a 2-mark question. That's a 2-mark question. You get 1 mark for getting one of these numbers right, and then you get your 2nd mark for getting 75. Okay. Kind of going on a bit there, but hopefully that helps a little bit understand how to tackle that question with a little bit more confidence in an exam. Now, we are going to look now at nth term sequences, which from what I remember on Tuesday, you guys were pretty good at. Like, I was very impressed, if I'm honest. So first things first, we spot what the number is going up in. So these numbers, always do that. These numbers are going up in 4s, okay? Can you see the gap between each one of these numbers is 4, so it's going to be 4n, okay? Then I do my 4 times table, 4, 8, 12, 16, 20. And I ask, how do I get from 4 to 6? How do I get from 8 to 10, 12 to 14, etc., etc.? I add 2, plus 2. So it's going to be 4n plus 2. Do you know what the crazy thing about maths is? That there took me maybe 20 seconds, and it was worth 2 marks. This question here took me about 2 minutes. And it got me 2 marks, got me the same amount of marks. So you'll find that sometimes things will be a lot quicker and you'll get the marks a lot quicker. Some things might take a little bit more time. However, don't give up. If it takes you a little bit longer, just stick at it, okay? Now, this is interesting because I gave you this question, but I didn't give it you as a multiple choice. Although it was, this on a calculator would be a multiple choice, okay? So it's quite worth checking out. Is your answer on there? Because if your answer is there, then you probably got the question right. If your answer isn't there, is it close to one that you think, actually, yeah, I'd probably go for that? Because sometimes it's worth doing a multiple choice question, long-winded, and then getting an answer and seeing if it is in the selection you've been given. Don't just circle one that looks right, because half the time they're trying to catch you out. Okay, so what I would do, I would pretend these didn't exist. Okay, so look, I'm covering them up. I'm pretending they don't exist for the time being. They're not going to influence my decision making, okay? They've gone. So 40, 35, 30, that's going down, isn't it? That's going down in 5s. So it's going to be minus 5n. So it goes minus 5, minus 10, minus 15, minus 20, minus 25. Now I ask myself, how do I get from my minus 5 times table to the sequence I've been given? How do I get from minus 5 to 40? How do I get from minus 10 to 35? Well, I have to add 45. Does that work for this one? It does, etc., etc. So it does all work out. So it's plus 45. Now, remember, guys, I said on Tuesday, in maths, they don't like to start with a negative number. So what they'll do is they'll flip it and they'll go 45 minus 5n, because then at least it's not a negative at the start. So this is what I would do. I would then go back to the answers I was given at the start and see if my answer is there. Is 45 minus 5n amongst the select? There it is. Hey, Zuzia, I've just seen you pop in. So there we go, guys. So that's how I can sometimes encourage students to work out multiple choice questions. Work it out without the questions there. Cover them up. Get your answer. And if your answer's there, happy days. If it's not there, have a re-look at the question, rework it again. Right, last question. and then we're going to move on to some Pythagoras, okay? So 5n minus 2. Can someone tell me what to do here? If I wanted to work out the third term, the third number in that sequence, what would I do? Five times 3, then minus 2. Perfect. So what Lottie's done there, Lottie's taken out the n and put the number 3 in there. So instead of it 5 times 3, yeah, perfect. So let's do that now. I'm just using this. 5 times 3 is 15. Take away 2 is going to be 13. There we go. Nice and big for you all to see that. But yeah, it would be 13 as my final answer. So let me just scroll down for the finale. Oh, look, you guys, yeah, everyone who put an answer in there got it right. So I'm pretty confident there you've got the gist of it. But yeah, whenever you want to work out a term, take the letter out, put the number in. Just do a straight swap, substitute it in, get yourself a number, get yourself an answer. Okay? But anything you're unsure about with regards to some of these topics that we've just covered there, we will be doing them again in class, in college. So don't think I didn't get that. Oh no, I'm screwed. I'm not going to remember this for the exam. We are going to revisit these over the next couple of, month or two. Okay? Right. There we go. Half an hour in. We've covered Tuesday's topics again. Just done a quick recap. I wouldn't say quick. We've done a 30-minute recap. We're now going to look at Pythagoras' theorem. Now, Pythagoras' theorem is coming up on paper 2. So what is paper 2? There it is. It's a calculator paper. So you are allowed to use a calculator for these questions, and the numbers are likely going to involve decimals, given the fact it's a calculator. Okay, but I like Pythagoras' theorem. 2 reasons why I like it. It sounds quite complicated, okay, but in reality, it's actually quite simple, and it's worth normally 3 or 4 marks. So I like it because it makes me sound more intelligent than I am. And secondly, if it came up on a paper, I'd be like this. Here we go, 3 marks in the bag. That's what I'd be thinking. So you'll see on my screen there, it says formula sheet. And then you've got Pythagoras' theorem and trigonometry. Now, you will now not have to remember the formula. Can you see here, there's the formula there? In the past, you'd have to remember a squared plus b squared equals c squared. You'd have to remember c being the longest side, etc., etc. You'd have to remember all the components and all the parts of that formula. But now you don't have to actually revise that necessarily because it'll be given to you on the formula sheet. So this here is directly snipped. I'm going to show you actually. Here we go. Just so you know, I'm not telling any porkies. Is the formula sheet here? Yeah, here we go. This was me yesterday when I was putting this lesson together. I went onto HUA's website. I got their foundation tier formula sheet, the insert that you'll get given in your exam. I scrolled down, and there we go. That's the screenshot that I took. Okay, so you will have the Pythagoras' theorem formula there for you in an exam. Now, what you won't have is a step-by-step guide on how to apply it. That's why I'm here. So, guys, this is the first triangle we're going to be looking at. Okay, now Pythagoras' theorem only works with a right-angle triangle. Okay, there's my right angle. And we want to work out the length of this missing side, okay, that long side there. Now, just so we remember, it's a squared plus b squared equals c squared. Now, for me, actually, no, not for me. C, this is for everyone. C is always the longest side. So we need to label this side here as C. And C is always opposite the right angle, okay? Let me tidy this up. I want you guys to have a good, clear note. So C is always opposite the right angle. Now, A and B, it doesn't necessarily matter when we know we're trying to work out C. Okay, so let's say A, let's say B. Once we've done that, what we need to do is take out the letters and put the numbers in. So instead of it being A, I now know A is 5 centimeters. Instead of being B, I know B is 7 centimeters. So what I can do is I can do 5 squared plus 7 squared equals c squared. Okay, then go one step further. Let's actually square those numbers now. So instead of it being 5 squared, 5 times 5 is 25. Now, let me just remind everyone, so we're all on the same wavelength. 5 squared means 5 times 5. 5 times by itself. Doesn't mean 5 times 2. Okay, and the same. Uh-oh, have you guys lost my screen? Have I lost internet? I have. Bear with me a second, guys. So basically, for some reason, my work laptop suddenly loses internet connection in this house. It's like it's cursed. So what I have to do, I have to reconnect to the internet. I then have to rejoin the call and then reshare my screen. Very annoying. So just bear with me a second. In the meantime, you guys get to just look at my face. I mean, there's a little fluffy. Oh, this is recording. I need to just shut up. Okay. Anyway, how's everyone? Let's just have a little bit of small talk. How's everyone? Having a good Easter so far? Good? Good. Oh, Zuzia, happy birthday. Oh, is your birthday today or has it been gone? Been and gone? Good. Okay, now we're about to have the best weekend ever. It was your birthday last week. Oh, okay. What day was it last week? I'm sorry if I forgot. I'm a busy guy. Anyway, hopefully you guys can see my screen. Can you confirm you can see my lovely blue triangle again? 30th of March. Oh, it was a week ago. We weren't in college though, were we? Excellent. Okay, right. Zuzia, happy birthday for last week, and I'm glad everyone's having a good Easter so far. That makes me happy, actually. I'm glad that's the case. So C is always the longest side. The formula we need is a squared plus b squared equals c squared. Okay. A we're saying is 5, and b is down here. Okay. So 5 squared plus 7 squared equals c squared. Okay. Now 5 squared, I know is 25, but if you're unsure, this is going to be on a calculator paper. Just use a calculator, okay? So 5 squared is 25. Mo, excellent. If you want to message me privately, Mo, with what answer you've got, then we'll check at the end. 25 plus 49 equals c squared. So you'll notice, guys, keeping c squared in there. What I'm going to do now is do 25, add 49. And that gives me 74. And that equals c squared. Okay, so step by step, let me just show you what I've done so far. I've got a value for a and b by labeling my triangle. I've substituted in those values into the formula for Pythagoras. So 5 squared plus 7 squared. In order to make my life easier, I've squared the numbers. So I've got 5 squared is 25, 7 squared is 49. And then you can see there's a little add symbol there that make our lives easier. Add them together, it gives us a whole number. The last thing I need to do, actually, I'm going to wait for you guys to tell me. What do you think the last thing I do is to get my final answer? So at the moment, I've got 74 equals c squared.
Square root.
Go on, say that again.
Is it square root?
It is the square root. Excellent, perfect. We square root that number there. So we get the square root of 74. This way, I say you're going to need a calculator today. So I don't know if you guys can see it. This blue screen, man, what is going on? Right. Anyway, it gives me 8.602325, etc., etc. What I'm going to do, I'm going to round it to 1 decimal place to 8.6, and then I'm going to leave the units in, so centimeters, and that gives me C. Now, this is something I want all my students to do, and it includes you guys as well, because you are now my guys. Okay. Once you got your answer, write it up next to the triangle. Does it look like it fits? Well, 8.6. Yeah, it does. It generally could be 8.6, couldn't it? Because if the next smallest side is 7, and that's 5, yeah, 8.6 looks perfect. If I got an answer of 92 centimeters, and I wrote up there, I'd be like, hang on a second, there is no way in my mind that could be 5, 7, and 92. Okay, so sometimes check your answer against the triangle, make sure it looks like it makes sense. Okay, now what I'm going to do, let me just check here. Let me just check, because I made this Desmos yesterday. I just want to make sure I remembered it correctly. How have I done this? Okay, yeah, right, perfect. What I'm going to get you guys to do is do 2 of these examples where you're finding the longest side. One of the examples is from the PowerPoint, and the other is from your February mocks. So let's see if you can remember your February mocks. Okay, so you've got that one to do, and then finally that one to do, and then we're going to look at finding a shorter side. Okay, so I'll put the link back into Desmos for you guys now in the chat in case you've just joined. There it is. So guys, get stuck in, use a calculator, pen and paper, sketch the triangle, because I think it helps you having that visual representation there. and just get stuck in. So what you can do. Try and arrive at an answer that you're confident and you're happy with. Okay, I'll shut up and I'll come back when I can see a selection of answers from you all, okay? I'll give you about 3 or 4 minutes. Hey, Smo, if anyone else has finished both questions, give me a shout and I can just check your answers. Oh, a lot as well. You guys are fast. I'm checking answers now because, like I said, the second question I'm getting you guys to do was actually a question in your marks. And most of my students, when I marked their papers, didn't pick up the marks. But now looking at it, we're looking good. Suja, that's absolutely fine. If you don't get it, that is absolutely fine. What I'm going to do, I'll go through both of these questions again, and I'm going to take my sweet, sweet time, make sure we're all singing from the same wavelength, okay? And if you're still unsure, I'm happy to put a bit of time out, put a bit of time aside to help go through it with you, okay? Okay, I'm going to wait a little bit longer for a few more people to get an answer for the second question. But I think with practice and repetition, this is a topic that I want to say a lot of students have access to and a lot of students can arrive at the right answer with. But it's just practice, 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 practice. All right, I'll be back in 30 seconds. I'm going to quickly grab a drink. And then when I'm back, we'll go through these two questions, okay? Okay, I'm back. But when you said bye then, it made me sound like I was leaving for good, like I was doing a runner. Okay, I'm back. We're going to go through these two questions then. And I'm going to just take my time. So Pythagoras' theorem is a formula that we can use to work out the length of a missing side. Okay, that's what it is. And essentially, it involves 3 letters, A, B, and C. And the formula is written like so. Let me just write it in red on the screen. A squared plus B squared equals C squared. So it sounds quite fancy. It sounds quite funky, but it's not too bad. What we need to do, first things first, label the triangle. So the triangle you've been given, put letters beside it. Now we know C is always the longest side, which is opposite the right angle. Okay, so it's always the longest side. In this case, we don't know what C is. A and B can be the other numbers, other sides. So we can say B is the base, A is this side here. Once we have A and B identified, we can actually take out those letters and put those numbers into play, okay? So it's called substitution. We're going to substitute 8 in instead of A, so 8 squared. And then instead of B, we can now put 5, okay? So we can put 5 squared. And that equals C squared. After that, what comes next? We actually have to square those numbers, okay? So 8 squared is 64, and then 5 squared is 25, and that equals C squared, okay? Beyond that, or further, the next step, let's add those two values together. Let's just condense that section, that side, into one. So 64 add 25 is 89, and that equals C squared. Now, when we think about algebra, solving equations, in order to get something by itself, we have to do the opposite. So you can see on here, it says C squared. We now need to do the opposite of squaring something, which is square root. Because if we square root C squared, it leaves C by itself, okay? So we have to do the square root of 89 now, and this is where a calculator definitely comes in handy. So square root of 89, and that gives me 9.4339. Well, it says it, give your answer to one decimal place. So if you can do that comfortably straight away, let's just do that. Right, 9.43391, etc., etc. Now, I've already alluded to this. I've already said it says one decimal place. So line goes in. What does the 3 do to the 4? Does it round it up or keep it the same? Well, it keeps it the same. So the 4 stays as it is. So it becomes 9.4 centimeters. And what can we do? Put it up here. Does it make sense? Yeah, does. Slightly longer than the next longest side. So happy days. I'm happy 9.4 is the right answer, and I can move on to the next question. Okay, so that's my best advice. Get an answer, check that you're happy with it, and then move on with confidence that you've got some marks in the bag. Okay, now this next question legitimately was from your mocks. Okay, so I screenshotted this from your mock paper and thought, you know what, let's give it to them in a relaxed environment. Let's see how we get on. Okay, so it doesn't. Do you know why I think not many of you answered this in the exam, or if you did, like, fair play, but it doesn't really scream Pythagoras. It doesn't tell me to, you know, it's just different to what we've just looked at. But yeah, it's a right angle triangle because it tells us here ACB is right angle, and we're missing the length of the side. So yeah, we're missing the longest side, which is C. Now, once again, A and B, it doesn't really matter. So let's just label that up there. Now, I'm going to try and squeeze it in here. A squared plus B squared equals C squared. Okay, so A is now 15. B is 7. And then C is still an unknown number, so we leave it as C. 15 squared. Now, I want to say it's 225, but I don't want to, yeah, it is 225. See what I mean there? Like, I had a gut feeling it was 225, but in the space of 3 seconds, I used my calculator and I confirmed that, okay? No, I wasn't leaving it from any error or any poor judgment. Used the calculator, confirmed my answer. So 225 and 7 squared, once again, use your calculator, just so you're not having any brain farts, is 49, okay? And that equals C squared. Next step, put those two numbers together. So 225 add 49 gives me 274, and that equals C squared. Okay. What's the next thing I want to do? The final thing I'm going to do, actually, not the next thing, the final thing is square root. Okay, so I want to get C by itself. So I'm going to do the square root of 274, which gives me 16.5529, blah, 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 blah. Now, it doesn't say here, give it to one decimal place or whatever it may be. So as long as you've got an answer roughly 16.6 or 16.55, you're in a fine position, okay? Now, I can't remember the mark scheme exact, but yeah, if you've got 16.55, for example, 2 decimal places, happy days, and you can just check that number up here. Does it look like it fits? Yeah, it does. It does look like it could be the right answer, okay? Yeah, 16.6 is fine, 16.55 is fine, happy days. Yeah, 16.6, I'm absolutely fine with that because you kept it consistent with the 1 decimal place. That's okay. Now, we are going to go back a sec to look at these examples. So now, we're not missing the longest side, we're just missing one of the shorter sides. Okay? Now, this is the bit we need to listen carefully to because there's an extra step involved. And I think if we listen carefully, I would say 95% of us will be fine. So let's listen carefully. Let's try and give this topic some respect. Okay, so we know it's a Pythagoras question. It's a right angle triangle and we're missing a side. So it's going to be a squared plus b squared equals c squared. Okay, that's my Pythagoras' theorem. Now, c is always the longest side. Now, because I know I'm missing one of the short sides, when I know I'm missing one of the shorter sides, I always label the missing side as A. I always put A as the missing side. It'll be like, A, I don't know you. That's how I remember it. A, I don't know you. So I'll always label it A. That's a bit weird, actually, I guess, but anyway. And then B is the other side, which in this case is 12. So now what do? We substitute. We take the letters out and we put the numbers in. So A is still something I don't know. So that stays as A squared. Okay, then B is going to be 12 squared. And then finally, C is 18 squared. Okay. Next step is to square those numbers. So once again, A squared, we still don't know what A is. So that has to stay as it is as A squared. But 12 squared is going to give me 144. And then 18 squared is going to give me 324. Okay. Now, this is the bit where I was saying like we need to really pay attention to. So I've got A squared plus 144 equals 324. Now, the aim of the game is to get A by itself, just simply A equals. So I need to get rid of the plus 144. And how do I do that? I have to subtract it. So I do 144, I have to take it away. And whatever I do on one side, I do to the other side, you know, like a seesaw. So to keep it balanced, okay, do the same to both sides. So what's going to be left on the left-hand side? Well, that's now been cancelled out. So I'm going to be left with A squared equals, and this is where I'm going to do this sum here. 324, take away 144, leaves me with 180. And the last bit, similar to what we've just been doing, if I've got a square, I need to do the opposite, I square root. Okay, so I do the square root of 180, which leaves me with 13.4. So A equals 13.4 centimeters, and that is 1 decimal place. Now, let me just quickly do a little check. 13.4. Well, yeah, it's smaller than 18. I know my triangle's a bit skewy, and this side looks like it should be the smallest, but it's smaller than 18, so I'm happy with that. Okay, as long as it's smaller than the longest side, you've done it right. And 9 times out of 10 in the exam, they'll give you, yeah, they'll give it you, and you'll be like, yeah, perfect. Okay, we'll do one more example with this triangle. So quickly take a second to copy that down, sketch it down. So you've got a triangle that is 12 meters in height, 22 meter slanted height, and we're going to try and work out the base of that triangle. Oh, refreshing. Okay, so I'm going to try and talk through it in steps. Step 1, write out the formula, which you will have in your exam on your formula sheet. A squared plus B squared equals C squared. Okay. Step 2, label the triangle. So C is always the longest side. A is the side I'm going to work out like, hey, I don't know you. Remember? If you think about why I'm saying that in such a weird way, I thought about that this morning. Like, hey, I don't know you. Hey, I don't know you. Oh man, I need to. Anyway, once we've got those sides labeled, we now have to substitute. So we take the letters out and put the numbers in. Okay. So A is still an unknown number, so that stays as A. B is actually going to be 12 squared, And C, well, that's 22 in this case, so 22 squared. Once I've got those numbers into place, I can now square the items and the numbers that I've got. So A squared stays as it is. 12 squared is 144. And then 22 squared, don't know that, I'm going to use my calculator. 22 squared is 484. There we go. So 484, excellent. Now, this refer back to what we were doing earlier. We want to get A by itself. I need to get rid of the plus 144, so I take it away. I take it away from both sides, okay? So what does that leave me with? Well, it leaves me with A squared on this side equals, now that's gone, obviously. 484, take away 144, it leaves me with 340. Like so. Last thing I need to do, my final step is to square root. So I need to square root 340. And I do that, and I get an answer of 18.4. So I can write here A equals 18.4. Now, already I'm looking at my thingy, and I know, right, well, this side here doesn't look, 18.4 looks longer than 12, like, yeah, blah. 18.4 is a longer number than 12, but this side looks smaller. That's my fault, because when I've drawn this diagram, I've not worked it out and put the numbers in the right place. I can guarantee in your exam, your triangle will make sense. Your smallest side will most likely be the smallest number, and your longest side will be the longest, and then the side that's in between will be the middle, okay? But when I put this PowerPoint together, I've not thought that far ahead. 18.4, I'm happy with that, because it's not longer than 22. If I got an answer of 25, I'd be like, hang on a second, it can't be right, because I know C is the longest and the biggest number, okay? Now, I genuinely do want you guys to give this a go and to practice it, okay? How many questions have I got you guys to do? 1, 2, 3, including the exam question. What I'm going to do, just because I'm going to get you to do 2 of them, I'm going to get you to do the pink triangle, and then I'm going to get you to do the exam question. So 2 questions based off of this, okay? So we need to do the pink triangle, and then the exam question, okay? And I'll leave this example on the board, on the screen. There's the link to Desmos. Just take your time with it. Give it a go. Now, if you are unsure, that's fine. One of my students did it the week before half term, Easter. They were confused. I said, right, 30 minutes, we'll go into a room, I'll draw some triangles, we'll practice it in person. And they left that room having the ability to do it. But let's try and master it online. And if we can't, we'll put time aside in person and go through it, okay? But I want you to give this a go. I'm going to shut up now and let you guys focus, and I'll be back in a moment. Yeah, similar to what Mo did earlier, and I think Lottie did as well. Let me know when you're finished, and then I can help you with some questions and I'm going through it, okay? Okay, I was looking at the second question, looking at some answers. Go away a little bit longer. But Mo and Lottie, you've both got the same number. So you've either both nailed it or you've both got it wrong. But I think you've, by the looks of your number, it looks like it should be right for the second one. And for the first one, from the answers that I've got, we're all on it. Yes. It's good my housemate isn't in, so I can be as loud as I want. So I'm going to give another minute because I want people to give the exam question a go, okay? So I do want to give people a chance to do that. Now, I will go through this for the people who aren't here. Obviously, the people who might watch the recording who are working or work experience or have overslept or whatever it may be. I will go through these two questions. But hopefully you guys, if you've got it right, you can have a bit of a breather. You can watch, reinforce what you've learned, etc., etc. But really, hats off if you've got these two right, because it's, like I say, a grade 4 topic. It would appear towards the end of a paper, I'd say, question like 20-ish. So it's worth having this in your locker. Can you believe we've been in the session for an hour? Time flies when you're having fun and doing maths. Let's have a look at these numbers coming in. So I'm going to give another minute, okay? Okay. Okay. Let's do it. So what I want you to do, bring your attention back to my PowerPoint. Now, if I was in a lesson here, I'd be like, put a thumbs up if you're listening. But it's not a lesson, so I'm not going to treat you guys like students in terms of the traditional sense. We're going to treat it as like mature learners. So the question I want you to do was the pink triangle and then also the exam question, okay? Calculate the length of the missing slide. Give your answer to one decimal place. And then there's a little extension on that. But we'll do the extension afterwards, okay? So calculate the length of the missing slide. Now, I'm going to do this in red so it sticks out a little bit from the black writing on the page. But a squared plus b squared equals c squared. Okay, label the side. So C is always the longest side, and that is opposite the right angle. Okay, so there's C. A, I don't know what it is. B, we can go for the base down there. So once we have that, we can substitute in the numbers. So A squared plus B, which is 8 squared, equals C, which is 23 squared. Okay, so what have I done? I've identified the sides of the triangle. I've substituted in the numbers for the letters, and now I'm going to square those numbers. So a squared stays the same. 8 squared is 64, and 23 squared is 529. What do I do next? Come into the chat here. What do I do next? What does one do next? Oh, not quite square root. You close, Lottie. We are going to get to that point. We've got to do one thing first. Kate Nicholson, excellent. We do. We have to subtract. Ah, perfect. A lot easier. You've clicked as well. Brilliant. No, that's good. We take away the 64 from both sides. Okay. So that is with me with a squared equals. So 529 take away 64 is 465. 465. And then now we square root. Now we do the final step, which is the square root, which gives me a squared, or a squared. A equals square root of 465 is 21.6. 21.6 meters to one decimal place, that is. Okay. Does that look like it's right? Yeah, it looks pretty good to me. Now, what I'm going to say to you guys, for the extension, I don't know if the area of a triangle will come up in the paper, but let's just quickly look at it. To work out the area of a triangle, do base times by the height, and then we divide it by 2. Okay? Well, the base we know is 8. We now know the height is 21.6. So if I do 8 times by 21.6, and then divide it by 2, I get the area of 86.4 meters squared. Which is quite interesting because I bought a house, woo, and I'm going to laminate the floors in the house, and I had to work out the area. And it's quite interesting. You realise when you buy out like things like that, you're like, oh yeah, I need area. And I've got certain weird shapes in my house where it's triangles and all sorts. So I actually had to use base times height divided by 2 literally a week ago, and I had to spend £600 on laminate. Whew. Whew. Anyway, last little bit. I mean, we'll have a 2-minute break because I don't want to drone on and on and on. I'll give us a little break. Right. Last Pythagoras question of the day. Here we go. Pythagoras, yes. A squared plus B squared equals C squared. Okay. A, B, C. Or C always alongside. A, side I don't know. B over here. Okay. Once I've got those sides, what I'm going to do next is actually label the diagram, or label the formula with the numbers. Okay. So instead of it being A, I was going to put an X, but I might as well keep it as A. So it's going to be A squared plus B, which is 3 squared, equals C, which is 8 squared. So yeah, do a switcheroo, get the numbers in where I can. Then I'm going to square them. So A squared plus 9 equals 64. Now I've run out of space here, which isn't ideal. But what I've got to do is get rid of the plus 9. So I do that by taking it away. Okay. Really not good that I ran out of space down here, but anyway, minus 9. So I'm going to be left with A squared equals 55. And the last thing I need to do is square root. So it's going to leave me with A equals, and then the square root of 55 is 7.4 to one decimal place. And then we put that down here. Does it look like it could be the right answer? Yeah, it's smaller than 8, slightly bigger than 3. Happy days. 3-mark question. Now, we know Pythagoras will come up. So that's definitely a good and valid reason as to why we should be putting time aside to mastering that skill, okay? So we'll do all we can between now and paper 2 to have that in our locker going forward, okay? What we'll do, we'll have a 2-minute break, and then we're going to come back and we're going to look at algebra, expanding brackets, factorizing, and then simplifying. That should see us through for 45 minutes. Very focused, very relevant. And you can see there, paper 2, paper 2, paper 3. So we know it's coming up. We know which papers it's coming up on. We can practice. Okay. So guys, 2 minutes time. Set your timer for 2 minutes. You might hear my voice pop back up in those 2 minutes. And then you know, right, back to it. Okay. So have a toilet break, get a drink, have a snack, whatever you need to do. And break. Good hustle. Okay, guys, we're back. Are you guys all here? This is probably where a good time to check if you guys are here. If you can message in the chat. Yes. Lottie's making a brew. Nice, good choice. We have another guest. We have Grace's dog. Ready to learn some algebra. Yes, dog. Dog maths. Excellent, James. But a few little minutes longer just to allow people to come back in. But guys, thank you. Like I said, I just want you to appreciate the fact that I know it is very easy not to be here. You could be doing anything. You could be watching a film, Netflix. You could be. I know the weather's actually quite bad today, actually, so it's probably a good thing you're here. But yeah, it's good that you are here. I appreciate that. Is it? It's a Thursday. Anything good on Thursdays? Nope. Nope. Okay. We're going to look at expanding brackets. So when I say expanding brackets, what I mean is multiplying them away. So when you expand brackets, it doesn't mean make them bigger. Okay. It means remove them, get rid of them. Okay. And the simple way to remember that is to multiply. Okay. You multiply what's on the inside by what's on the outside. And I think I mentioned this to one of my groups a couple of weeks ago, is that sometimes it comes up in a few questions later on in the paper. And even if you just expand the brackets, you pick up marks. So you may not have a clue what to do with some of the numbers beyond that point. But if you expand the brackets, the mark scheme might be like, yep, they've done that. Good, give them a mark. So this is a skill that could get you marks early on in the paper, but also at the end of a paper. So it's a really good skill to have up your sleeve. Now, like I say, it's all about multiplication. So we times what's on the outside by what's on the inside. Okay, so I call it Noddy's hat. It helps me do this. So 3 times x gives me 3x. 3 times 3 is 9, and it's a positive number, so plus 9. There we go. I've expanded those brackets. 1 mark for that. Let's have a look at this next one. I'm going to go down. So 4 times x is 4x. 4 times minus 3. Okay, well, what you could do is 4 times 3. Realize it's a minus 3, and it'll be minus 12. So you can see I'm timesing the numbers, and I'm expanding. The brackets have gone. I've achieved my goal. Okay. Now on the right hand side, it gets a little bit spicier because we have an x on the outside as well as on the inside. Okay. Do not fear. Just focus on the numbers first. We're in a math lesson. Let's focus on the 6 and the 4. 6 times 4 is 24. Now I've got to do x times x. What is x times x? What would that give me? We do it up here, for example, x times by x. What's that going to give me? James short x on it. It does. It gives me x squared. So that one's going to be 24x squared. Okay, good. Yes, perfect, guys. Good, good, good. Then 6 times 2 is 12, which is a positive number, plus 12. Don't forget about the x. Put that on there as well, because if it's on the outside, it needs to be carried across. Okay. So there we go. 24x squared plus 12x. That's what I've essentially just worked out there. Not too bad. We'll now look at this one here. Now, the bottom one, the one that I've not done, could look a little bit intimidating. So let's just take our time with it first. A singular x, can you see how it's just x by itself? That means there's just one of them, okay? So minus 2 times by 1, well, it stays the same. So that's going to be minus 2, okay? X times x we've established is x squared. So it's going to be minus 2 and then x squared. Now this is the juicy bit. We've got minus 2 times by minus 4. A minus times a minus gives me a positive answer. So minus 2 times by minus 4 gives me plus 8. And remember, if there's an x on the outside, there's going to be an x there as well. Plus 8. Excellent, like, thank you, did my work for me then. I appreciate that. But yeah, what I've done there is I've just got rid of the brackets by expanding, by multiplying, okay? Now, it is a skill that just needs practice and repetition. You do a few of these and you'll be like, yep, quite confident with these now. Some of them will take longer than others because there's some of them are more complex than others, but just take your time and try and apply the rules of maths. A negative times a negative will give you a positive answer, okay? If it's a negative times a positive, it'll give you a negative answer. So that's where these symbols come from. Okay, can you see here, that's a positive 4 times by a negative 3, so it gave me a negative there. But I think the best thing for me to do is to probably be quiet and allow you guys to tackle these 6 on the screen, okay? So there's the link to Desmos. On Desmos now, I'm going to paste it so you guys can see those 6 questions. Get stuck into those. Get stuck into those. And then what I might try and do quickly is pull up the exam question I referred to previously, if I can find it. Oh, there it is. Excellent. So we'll do these 6, then I'll just quickly show you that exam question. Once you've finished, guys, let me know in the chat. So I'll give you guys another minute or two just to finish those selection of questions. I'm going to group all your answers, but we are looking pretty good. You guys are a good bunch, aren't you? Excellent, Lottie. Thank you for confirming. I was going to say I'll put on some background music, but I feel like that would put people off. Because you guys would probably criticize my music taste, so I'm not going to do that. Okay, another 30 seconds because the people saying they're done is filtering through, which is excellent. But you guys have similar speeds. So I'll put a little 30-second taster on, okay? What was I listening to before the lesson? All right, Andy. A. not just a maths lesson, it's a party. What these sessions are about. Right, let's look at these questions then. And I think I've probably got enough space. What I have done is separated the questions on other slides, but I reckon I can do it all in one. So it goes without saying, you guys blitz the start, and I think you're looking really healthy for the second, and the second to last and the last question as well. So I think what I'm going to do is just quickly show you, right, 3 times x gives me 3x. 3 times 2 gives me 6, positive number, so plus 6, okay? 5 times y is 5y. 5 times 6 is 30, but it's a negative 6, so it's a minus 30 there. Minus 4 times 2x, so that's going to be minus 8x. Minus 4 times by minus 8 is a positive, because it's a minus and a minus, and it's plus 32. Okay, so yeah, done those. Okay. 2 times 3. Oh, I thought I was muted then. 2 times 3 is 6. X times x is x squared. 2 times 5 is 10. The plus. Don't forget about the x. 10x. Okay. 4 times 3 is 12. Y times y is y squared. 4 times by minus 2 is minus 8. Don't forget about the y. Put it on at the end. Last little bit. Minus 5 stays the same. X times x is x squared. Minus 5 times by minus 7 is plus 35. But don't forget about the x. Okay? Do you guys like how I call it Noddy's hat? Do you guys even remember Noddy? Yeah? So remember, when you're multiplying out, remember Noddy's hat, okay? Hopefully, that's giving you some practice there. Now, like I say, some of you may be like, yeah, I was already pretty good at that. That's fine. But I think the more practice, the more you can reinforce it, the better. Now, what I did say was that this could come up at the end point of an exam on a later question, and just doing that simple job there might get you a mark. So let me just show you that in action. So let me just discard that working out and go to this question here. So this is, look at this, look at this, look at this. I'm zooming in here right now. Question 30. Question 30 on paper 2. Okay, and what do we have here, guys? What's that there? How do I do it here? 2, open brackets, 2x plus 20. You get 1 mark for expanding that bracket. So you may look at that question and think, I have not the foggiest what I need to do. However, you zoom in, you spot there's an opportunity to expand brackets. You expand those brackets. So this was question 30 on your paper 2 mock paper. Okay. So guys, just in the chat, expand those brackets for me as I look out into the rainy distance. Expand those brackets. What are you saying? Got 2 open brackets, 2x plus 20. For those of you who are writing 4x plus 40, that is 1 mark you've just achieved. And how many marks is this question in total? 3 marks. So you may not have a clue about the diameter of the circle and all this, what's going on here. But you've expanded those brackets, that's 1 mark, done. Imagine getting that 1 extra mark just at the end of a paper, just because you have to expand brackets. That's why it's such a good skill to have, because it does come up in other areas, and it's a simple skill that you can apply quite comfortably, even in like isolation, okay? Right, we are now going to look at the opposite. So we've looked at expanding brackets and getting rid of them. We're now going to look at factorizing. Factorizing is where we bring the brackets back in. And I actually quite like this. Ooh, I forgot I had this question. So this question here was on November 2021, paper 3, question 17. So this is a calculator paper. Once again, do you guys want to put your answers in the chat? Yeah, let's do it. What would you get for that sort of question there? This is 2 marks, this question. 2 marks. You guys just give me a shout. What do you reckon? Multiply out 5x, open brackets, 3x minus 2. Let me draw my Noddy's hat. That's the motto. Good job I'm not a music teacher.
I know how to do.
Go on then, what's your answer?
So it's 5x times 3x is 15x squared.
Excellent.
And then 5x minus 2 is 10x minus 10x.
Minus 10x, excellent, good. And your brain worked exactly how my brain would have worked then. I'd have done 5x times 2 is 10x. And don't forget the minus. Perfect. As long as you've got those there. Now, let me just break down where you get your marks for that. You get a mark for getting this bit correct. Okay, and then you'd get a mark for getting the minus 10x bit. Okay, that's where the 2 marks come from. So guys, how about that 2-mark question? You guys have all shown me you have the ability to do that, which makes me a very happy chappy. Okay, we're now going to look at factorizing. So factorizing is the opposite. So instead of taking out the brackets, we are now going to be putting brackets back in. Now, when I teach this online, a really clear giveaway that students aren't listening is the fact that their answer doesn't have brackets. The very first thing I do when I see the word factorize, I draw some brackets because I know I need to put brackets into my answer. Now, I'm going to teach you this to the highest level, which gets you the most marks, okay? And that is where we fully factorize, okay? Now, why has my pen done that? When I mean fully, okay, what I want is the biggest number that goes into both 4 and 8 on the outside. So the biggest number that goes into both 4 and 8 goes on the outside. So tell me, what is the biggest number that goes into both 4 and 8? The number 4. Because 4 goes into 4, but 4 also goes into 8. Okay? So 4 is the biggest. So if we want to do it fully to get the most marks, put the 4 on the outside. Okay? Then I have to think, how do I get from 4 to 4x? How do I do that? Well, I have to times it by x. That's that bit done. Then I ask myself, how do I get from 4 up to 8? I have to times it by a number, and that number is 2. A little plus there, so it'll be 4x plus 2. That is fully factorized. The biggest number is on the outside. Okay, let's do that again, but we'll do it for this one here. What is the biggest number that goes into both 5 and 15? What's the biggest number that goes into 5 and 15? 5, excellent. So we put 5 on the outside. How do we get from 5 up to 5x? I times it by an x. How do we get from 5 up to 15? I times it by 3. It's a negative, so it's going to be minus 3. Okay? So if you factorize, you get 1 mark. If you fully factorize, if you put the biggest number on the outside, you get the extra mark. Okay? You get 2 marks. Now, we're going to go up a notch here. Look at these questions. Spicy, okay? I'm going to put 2 chilies up here because they're a bit spicy. Okay? Guys, tell me. Factorize, brackets go in. What is the biggest number that goes into 6 and 3? Biggest number that goes into 6 and 3. Abby's on it. It is 3. So 3 on the outside. Now, this is something I want you to spot. Okay? There's an X on this side as well as this side. So an X goes into both sides. And if it goes into both sides, it needs to go on the outside of the bracket. Okay? So I need to put an X on the outside of the bracket. Okay? Hopefully that makes sense. Because there's an X on this side, and there's also an X on the right side. So an X on the outside, needs to happen. Now, how do I get from 3 up to 6? I times it by 2. How do I get from x to x squared? I have to times it by another x. Okay? How do I get from 3 to, well, how do I get from 3 to 3? Well, I have to times it by 1. And the x that's here is already on the outside, so I don't have to do anything more. I can then look at the symbol, which is a plus, and chuck that into the middle. Okay? So we've got 3x, open brackets, 2x plus 1, and then close brackets. Do one more, and then I'm going to get you guys to practice. So 14 and 21. Brackets go in. Now, I know the number 7 goes into 14, and it goes into 21, so 7 goes on the outside. There's an x on the left side as well as the right, so if it goes onto both, it goes on the outside of the brackets. How do I get from 7 up to 14? I times it by 2. How do I get from x to x squared? I have to times it by another x. How do I get from 7 up to 21? I times it by 3. But the x that I need here is already there, so I don't need to put another x in it after the 3. It's a plus, so I'll put a little plus between those terms there. Okay? All right, well, yeah. So I tell you what, this is a spicy part of the session. This is spicy. This is an extra level of complexity. However, with practice and repetition, I say that a lot, you'll be like, okay, right, I'm in the flow. I know what I've got to do. So how many questions have I got for you guys to do? I've got 5 for you to do with a particularly juicy question towards the end, okay? These two, D and E. So what I'm going to do, I'm going to get you guys a chance to practice. Now, this is probably the best part of the session to practice on because I know this is quite tricky, but give it your best shot. You've got nothing to lose at this point. Because like I said, what we'll do on next Tuesday is we'll go through this again as well. So we'll just practice this skill. So we'll introduce it today, practice it, and then hopefully on Tuesday, package it together so we've got it in our locker. Okay? So work through those questions, give it your best effort, and then we'll review them together. Okay? See, Lottie said she's finished. It's really encouraging signs here, though, like genuinely. Most of you are there or thereabouts, which is good. It's just got to fine tune it. A bit like I don't play an instrument, but you know when you like play a strum a guitar and you're like, right, it's nearly there, just needs that little minor tweak. I feel like that's where we're at. Like a child with fluffy hair. Okay, 1 more minute, and then we're going to go through these, okay? That's the motto. Okay. I think that minute is just about up. So what I want you to do, bring your attention back to the old PowerPoint. I'm just going to talk you through factorizing with these 5 questions. And I might leave the lesson there for today because I do think a 2-hour slot is quite heavy and intense online. And I think I don't want us to go beyond that. So I think 1 hour 50 is about right. Similar to what we did on Tuesday. Keep the vibes positive, keep our energy up quite high. Okay, so pen at the ready. When it says factorize, legitimately, guys, in your exam, you need to have your brain go brackets. The word factorize, think brackets, okay? Because that's step 1. And if you can do that, then you think, right, okay. But like the first domino that falls, it's like, right, okay, my brackets are in. What do I do next? Oh, yeah. What's the biggest number that goes into 15 and 20? 5. Okay, so 5 on the outside. Okay, how do I get from 5 up to 15? And can you see like the rest starts to flow? So think brackets, then the biggest number. How do I get from 5 up to 15? I times it by 3. Remember, I want an x though. So the x needs to go just in there. There we go, 3x. I then need to think, how do I get from 5 up to 20? I times it by 4. So I've got 5, open brackets, 3x plus 4, okay? Now I can see lots of you got 5 on the outside, and I can see lots of you got 3s and 4s on the inside as well, which is really good. Just make sure we've got the 5, 3x, and then the plus 4, okay? Next one, 6x minus 18, brackets go in. Biggest number that goes into both is 6. Little x there. How do we get from 6 up to 18? I times it by 3. Little minus symbol, minus 3. So 6x minus 3. Okay. Let's have a look at C. So this is where it starts to get quite interesting. Okay, this is where your answers vary a lot. So let's have a look. Let's see what I can arrive at. So the biggest number that goes into 4 and 10 is 2. Okay, which everyone has got. Brilliant. Now there's an x on this side as well as that side. So there needs to be an x on the outside, which most of you have got. Okay. Now I think, how do I get from 2 up to 4? I times it by 2. How do I get from x to x squared? I times it by another x. How do I get from 2 to 5? No, 2 to 10. I times it by 5. There's already an x on the outside, so I don't have to put another one on the inside. But I need to put a little symbol, a little plus, okay, because of that there. So 2x plus 5. Okay, we're really close. We are really close. And I'm quite looking forward to doing this again on Tuesday, because I think sometimes once you've been introduced to it, done a little bit of practice, your brain takes a couple of days to process that, and then it does kind of line things up better. Okay, here we go. Factorize these two. Look at this. Brackets go in. The biggest number that goes into both 12 and 20 is 4, okay? I've got an X over here as well as an X there. So there needs to be an X on the outside, okay? How do I get from 4 up to 12? I times it by 3. How do I get from X to X squared? Well, I have to times it by another X, okay? It's got a plus there, so let's put a plus here now as well. How do I get from 4 up to 20? I times it by 5. Now, the X that I need is already on the outside, but I don't have a Y on the outside, so I need to put a Y on the inside. So I've got 4X, open brackets, 3X plus 5Y. Okay? And this isn't something I've said to do yet, but if you want to, and you've got time in your exam at the end to check, or after you've done your question, try and expand those brackets and see what you get. Because you may realize by expanding the brackets, you've either nailed it or you've gone slightly wrong, and it allows you to reprocess the situation. Okay? Now, this last one, we're going to finish on this. So let's just finish on a positive. Let's finish strong. Big brackets. Okay? The biggest number that goes into both 15 and 9 is 3, which you guys are all getting this spot on with. You're all getting this number spot on there. Now, there's an X on the left and on the right, but there's also a Y on the left and a Y on the right. So 3XY, which I don't think anyone's actually done. So yeah, if there's an X on both sides, but also a Y on both sides, it goes on the outside. Okay? So we've got 3XY. Now, this is the bit where I ask myself, how do I get from here to here? Well, how do I get from 3 up to 15? I times it by 5. How do I get from X to X squared? I have to times it by another X. The Y that I need here is already on the outside, so that's fine. I'm done. I've done that bit now, so I can introduce the plus. How do I get from 3 up to 9? I times it by 3. Now, I need an XY. Well, as you can see on my answer, I've got XY already on the outside. So I can leave the 3 as it is. And that is my final answer. Let's make this bracket a little bit tighter now, just to, there we go. It's kind of crazy. The more stuff you have on the outside of the bracket, the less stuff you need on the inside. That's typically the way it goes, okay? But remember, we're always multiplying the numbers, okay? So I think I saw one student put a 6 here, because I think they slipped into the whole 3 add 6 gives you 9. But remember, if we did 3 times 6, it would give us 18 afterwards. So remember, we're always timesing them. So make sure you always think, right, how do I get from here to here using my times table? It is genuinely a big case of practice now. It's just going through each one of these and practicing. I think what we'll do on Tuesday is, I won't do a Pythagoras starter. I won't do Pythagoras, but we'll do a little bit of algebra starter and then move on to other topics, geometry, statistics, things like that, okay? But guys, like, I don't know about you. I feel like that's gone very quickly. I don't know if that's good or a bad thing. Hopefully you found it beneficial. Now, even if you're sat there, you're like, I'm completely lost, don't panic, don't stress. You have over a month before your first exam. These topics are coming up on paper 2, so you've got about a month and a half. You'll have a chance to catch up with me in the classroom, catch up with your teacher in class, in college, whatever it may be. This is an introductory into some of these, because you may have not done this topic for a long, long time. Okay, so don't beat yourself up if it's not quite snappy yet. We'll do a little bit more practice on Tuesday as well. But yeah, when we're back in college, revision, we'll get you there, okay? Guys, as always, you've been phenomenal. Your efforts on Desmos, your efforts in the chat, don't go unnoticed. I appreciate all your input and all your efforts. I just want you guys to relax now. We'll next get together on Tuesday, where we'll do another planned session, and hopefully you find it, helpful and beneficial in terms of your revision. Okay, but guys, yeah, relax, do a little bit of work between now and then, practice those skills, and then you're good to go. Okay. Cheers, James. Thank you. See you, Grace. See you, Lottie. Emily as well. Thank you. do I stop recording now as well? Cheers, Mo. Thank you as well for being here as well. I appreciate that.